Hey quality geeks, how are you all doing? This is the first video presentation of a 21 chapter video series on Agile testing. If you're remotely interested in this topic, I think you might find this exciting. Don't forget to subscribe and enable notifications so that you stay posted. Having said that, fasten your seatbelts. All my videos are based on this Agile Testing book by Lisa Crispin and Janet Gregory. I've tried to summarize the content and capture the most significant bits of the book in this video series so that you don't have to read the entire thing. In the first chapter, we'll take a look at the Agile values that should guide us in building good quality software. We'll highlight the whole team approach towards quality, what we mean by Agile testing, the differences between traditional versus Agile models, and the interactions between the two sub-teams of Agile, which is the customer team and the developer team. Let's first take a brief look at the Agile Manifesto. Agile software development has a mission of uncovering better ways of developing software. We won't be discussing the Agile methodology in detail, but we will be using its manifesto to guide us. So one of the first values of Agile is to value individuals and interactions over processes and tools. And if you see, I've highlighted the green and the orange here. Green are the values that we prefer over the values in orange, which is processes and tools in this case. That's not to say that we don't value processes and tools, but it's just that we value individuals and interactions more than what we value processes and tools. The idea here is that sometimes we get too bogged down by trying to decide which tool is going to fix our problems, but what might end up fixing our problems are more interactions between individuals and brainstorming sessions that could be more beneficial than strict processes and tools. Customer collaboration is valued more than contract negotiation. One of the examples here is that let's say you estimate that a project costs $1 million and needs 5 people. But then if you start negotiating a contract with the program managers or the marketing team and so on, they might say something like, "Oh, can you do this in $500,000 and with 2 people or 1 person?" So in the end, you might end up spending $500,000 and not saving $500,000 because you might end up building something that the customer doesn't really want. So that's why we value customer collaboration, so that the customer is engaged from the get-go. Working software is to be preferred over comprehensive documentation. One of the things that happens usually in the fast world of technology is that documentation goes obsolete really quick. So we always want to strive for making a working software in short release cycles than having extensive documentation just for it to go obsolete. We want to respond to change than following a plan. Sometimes what happens is that you will spend an entire quarter just planning things only to find out that you need to respond to market conditions, competition, and so on. So you should always be ready. You should build a software in a way that you're ready to respond to any kind of change, whether in the market or within technology. Agile testing promotes the whole team approach. It is central to the attitude towards quality and testing. The whole team is the Agile team. We will visit this in some more detail further ahead in the presentation. In order to ensure that we speak a common language, it's important to clarify the misunderstanding that may arise between these 3 roles. In an Agile team, everyone involved in delivering a code is a developer: architect, programmers, testers, system administrators, release engineers, etc. They're all developing tools and infrastructure in their own domain. The author suggests that we use the terms programmer and tester for convenience, as opposed to a developer and tester, because testers also are developing code. They may just not write production code. Let's read an excerpt from chapter 12 of Alice's Adventures in Wonderland, where the king orders the white rabbit to read a letter of evidence where the rabbit says, "Where shall I begin, please your majesty?" he asked. "Begin at the beginning," the king said gravely, "and go on until you come to the end, then stop." Except we should do the opposite for test-driven development. Agile programmers use test-driven development, or TDD, to write quality production code. In test-driven development, we have seen that as complexity of the system grows, it's not possible to formally prove its correctness. The only solution is to put the system to test. Moreover, while developing an application, it's advisable to be goal-driven, to be clear in mind what the objective is and how the code should function when presented with a given test. In a nutshell, test-driven development begins at the end with a goal in mind and works its way back to the code that delivers this goal. Here's an example. In summary, in this example, let's say you're trying to build a simple counter, right? So you can see here that the test case is making an assertion to test if the counter correctly increments the value by 1. And whenever the counter gets implemented, this test will automatically verify its integrity, that it is actually incrementing it by 1. So this is the test code that's been written before the code is implemented. And here you can take a look that finally when the counter module is implemented, then these tests could run and verify if the counter is doing the right thing. The whole idea behind this is to place a constraint on a programmer so that we can test early and test often to prevent issues from surfacing later on. It acts as a design constraint, in short. This is a tongue-in-cheek take on what it's like to use test-driven development for TDD for development. So while this comic is funny, it does not truly represent TDD. With TDD, the programmer writes a test for a tiny bit of functionality, sees it fail, writes the code that makes it pass, and then moves on to the next tiny bit of functionality. The test is written before the actual code is implemented. This acts as a constraint for good design very early in the development cycle. This is what it means to say quality is baked in. Programmers also write integration tests to make sure that small units of code work together as intended. Luckily, the failure of code in development environment is nowhere close to being as costly as running a car off the bridge. Some testing approaches like exploratory testing are inherently agile, whether it's done in an agile project or not. Testing an application with a plan to learn about it as you go and letting that information guide your testing is in line with valuing software and responding to change. And just because you're testing on an agile project doesn't mean that you're agile testing on a project. The agile team consists of 2 sub-teams, the customer team and the developer team. The customer of the product includes business experts, product owners, domain experts, product managers, business analysts, and subject matter experts. Everyone who is in the business side of the project belongs to this team. The customer team writes the stories, feature sets that the developer team delivers. They provide examples that will drive coding in the form of business-facing tests. They communicate and collaborate with the developer team throughout each iteration, answering questions, drawing examples on the board, and reviewing finished stories as a part of stories. Testers are integral members of the customer team. They help elicit requirements and examples. They also help the customers express their requirements as tests. The developer team. Everyone involved with delivering code is a developer. Agile principles encourage team members to take on multiple activities. Programmers, system administrators, architects, DB administrators, technical writers, security specialists are all part of this team. Testers are also on the developer team. Testers advocate for quality on behalf of the customer and assist the development team in maximizing business value. So the tester is a part of both the customer team and the developer team. The customer and developer teams work closely at all times. Ideally, they're just one team with a common goal. The goal is to deliver value to the organization. Agile projects progress in iterations, which are small development cycles that last from 1 to 4 weeks. The customer team, with input from the developer team, will prioritize stories to be developed, and the developer team will determine how much work they can take on. They'll work together to define the requirements with tests and examples. Let's take a look at the classic waterfall model, where testing is considered merely a phase that happens after coding is completed. Surprisingly, this is still an active model of development in many organizations, despite its inefficiencies and shortcomings. The code is thrown over the wall to the testers, usually without accountability for quality, and testers are expected to find bugs and be gatekeepers of a release. This diagram assumes that testing gets equal time as coding. In reality, the testing phase is much shorter than the other phases. Not only is there not enough time to test, but every time we discover a bug, we get into a code plus fix cycle. Every time this happens, we have even less time to test than what we began with for testing regressions. The new fix might have introduced regressions in other areas areas of the code. We cannot assume that one change in one component may not affect other parts of the system. This creates a downward spiral for quality of the product, especially since team will inevitably start taking shortcuts under the looming threat of a deadline to release the software. That's the code plus fix cycle. Gated approach usually ends with a rushed testing phase. This subsequently leads to either a low quality or a delayed release. As leaders of quality engineering teams, we're often expected to act as gatekeepers of quality. We couldn't control how the code was written or if the programmers have even tested their code, other than by their personal efforts at collaboration. Our post-development testing phase are expected to boost quality after the code was complete. This is an unrealistic expectation. Ultimately, it all translates to cost. The national cost estimates of an inadequate infrastructure for software testing are estimated to be $59.5 billion. This represents 0.6% of the USA's $10 trillion GDP. This report is quite old. This report is from May 2002. There's a much newer report from Tricentis from 2017 that highlights the colossal impact of software failures in production annually. Although these numbers are at a global scale, unlike the previous slide, which was specific to the USA. I've included the references in the references slide at the end of the presentation if you're interested in their methodology of gaining these statistics. I want to talk about the most expensive hyphen in history. When the Mariner 1 spacecraft was launched in 1962, it was the first attempt made by the US to send a spacecraft to Venus. A software bug caused the rocket to veer off course. A NASA range safety officer on the ground issued a self-destruct command, which destroyed the spacecraft 290 seconds after takeoff. One of the official reports was that the omission of a hyphen in the computer-coded instructions in the data editing program resulted in the incorrect guidance signals being sent to the spacecraft. The cost of the rocket was reportedly $18 million at the time. That would be around $154 million, a whopping $154 million in 2022. And the point here is that the triviality of the error may be severely disproportional to the impact it has in terms of cost and reputation. Also, that finding this issue earlier and not later could exponentially save us time, money, and reputation. We should always strive for excellence and raise the bar for testing. Test early and test often is the message. A quick note on incrementally baking quality into the product. How customer is the one that decides the quality criteria and not the QE team. Example, let's say you're building an e-commerce website for a customer. It's a startup company and the tester finds that the application crashes when 10 users are logged in concurrently. Even though it's a serious bug, it may be unwarranted to block the code release if all that the customer wants to do is, show the website to potential customers with a single user login. So this means that the quote-unquote flawed code could still be pushed to production as it doesn't affect the customer scenario or the customer requirement. This is what it means to deliver small chunks of functionality based on what the customer needs and as they need it. Or at the very least, the customer is okay having this flaw in the product at that particular point in development. Agile is iterative and incremental. This means that the tester tests each increment of the coding as soon as it's finished. Note that these tests are tests that the tester may execute in addition to those that are already written and executed by the programmer before implementation using TDD. An iteration may be as short as a week or as long as a month. The team builds the test little by little and just make sure it works correctly and then moves on to the next piece that needs to be built. Programmers never get ahead of testers because the story is not done, quote unquote done, until it's been tested. It should be possible to release software after every iteration. This chart demonstrates the contrast between how frequently we test our code versus how often we test our code. So if you see the third blue bubble on the bottom right is a common place for traditional models of development. The code is tested less frequently, that is few times during the testing phase and all requirement gatherings, when all the requirement gathering and the coding is complete. And it is tested much later in the development cycle. In contrast, if you look at the top left bubble, that shows the code has been tested 20 times and much earlier in the development cycle. Ideally, this is the place we want to be in. If we're not there, then we should strive to push towards it. In short, the holy grail of agile testing is summarized eloquently by this phrase: test early, test often. This ought to be the fundamental premise of any development in order to achieve excellence in quality. Let's revisit the whole team approach again. One of the biggest differences in agile development versus traditional development is the agile whole team approach. With agile, it's not just the testers or a quality assurance team who feel responsible for quality. We don't think of a quality department. We just think of skills and resources we need to deliver the best possible product. Building a high quality product is the job of the whole team, not just the testers or designated quality engineering teams. Test infected. Everyone on the Agile team gets test infected. Tests from the unit level on up, driving the coding, help the team learn how the application should work, and let the team know that we're done with a task or a story. Producing quality code might mean including specialists on the team, such as expert testers. It doesn't, however, limit particular tasks to a particular team member. This means that the team takes responsibility for all kinds of testing tasks, such as automation, manual exploratory testing. It also means that the whole team thinks constantly about designing code for testability. It's easier to test code which is designed for testability. Imagine a hockey game as an analogy. While the goalie is an expert at stopping shots, would you leave the goalie by themselves to prevent the goals? That would be a disastrous defensive strategy. The whole team moves back and forth in front of the goalie to challenge attackers, intercept passes, and guard the goalkeeper as much as possible. That's the whole team approach to defense, and that should be the whole team approach towards quality. The whole team approach requires constant collaboration. Testers collaborate with programmers, customer team, and the other team specialists, not just for testing tasks, but other tasks related to testing, such as planning, building infrastructure, and designing code for testability. There is a mindset shift involved in agile testing as well, and I think this is a very important part about agile testing. It's not just the tools and infrastructure and the process, but it's also the mindset. I think agile testing is a mindset. It's no longer about finding bugs during the testing phase. It's about proactively preventing bugs by facilitating good design. There it is, preventing bugs. The term agile is sort of a misnomer because some folks who are new to agile perceive it as all about speed. The fact is, it's not about speed as the name suggests. Agile is about quality. And if it's not, we question whether it's really an agile team. Every team situation is unique. That's why we need to be aware of the potential testing obstacles our team might face, that our team might face, and how we can apply agile values and principles to overcome them. Before we conclude, I want to highlight the mindset behind agile testing using a perfect triangle analogy. The perfect triangle is an abstract entity and doesn't exist in reality as a concrete object, unless you're a mathematical realist, but that's for another day. Even the triangle on the top is flawed, as if we were to zoom far enough, it would pixelate. We will never see a perfect triangle, but from the fact that we can judge how these pictures are flawed, and that the third one on the right is less flawed than the first two, clearly we have a sense of what a perfect triangle would be. Similarly, we can lend our intuition to guide us what changes we can implement to our development process to test early to achieve that ideal product. It's not a formula that'll work for every team, so you have to really work towards it. We may never be able to achieve the perfect process that builds the perfect product. However, we must strive to get as close as possible to the ideal. In summary, we discussed how we can let Agile Manifesto be a guiding force towards testing. We clarified terminology around developer, tester, and programmer. We discussed test-driven development as it relates to Agile and focus on business value. We also looked at shortcomings of the traditional model, and finally, we emphasized the value of whole team approach in this presentation. In the next presentation, we will discuss the 10 principles for Agile testers in some detail, what it means to be an Agile tester, the Agile testing mindset, and how these principles could add value to the team. Here are the references if you're interested. And with that said, thank you for your time. Have a good one, and don't forget to subscribe if you're interested in quality engineering stuff. Geek out.